Okay, so with incomplete dominance, the best way to think of it is when you have two alleles that mix, so the two phenotypes mix together, and that's because you don't have an allele that completely expresses itself. So there's no dominant allele, and you get a mixing of the two alleles present. So in this example, they've shown two pink flowers that have crossed with each other, and they've showed the resulting offspring. So the key thing to keep in mind here is it's pretty much the same thing you've been doing before with Punnett squares and monohybrid crosses, but the difference is now in how we write the alleles. So in this case, this question here is asking us what's the result between a red snapdragon and a white snapdragon. So let's start off first by writing our genotypes for these two parents. So for the red, we would have a capital C and an R, and again a capital C and an R. And again, that's the only way we'll get a red flower in this case, if it has two copies of the red allele. And our white snapdragon would be the opposite. So we'd have a C with a W and a C with a W, because again, the white flower can only be present if that flower has two copies of the white allele. So let's see what happens when we cross these two together. So you're going to set up the same way like you would before. One CR will go here, the other will go here, CW here, CW here. And now we're going to do a simple cross, and you'll see once we do this, we end up getting the same thing in all four squares. So if we're looking at our genotypic frequency, we only have one here, which is CR, CW, that's 4 to 4. And our phenotypes, in this case, we would only have one, and they would all be pink, 4 to 4. Because we have one copy of the red, one copy of the white, and because neither are completely dominant, you get a mixing of red and white. When you mix red and white together, you get pink. So hopefully that makes sense.